Okay, Assalamualaikum warahmatullahi wabarakatuh. Very good morning. Okay, first today we will start our lesson studying the chemical properties of alcohol. So, chemical properties of alcohol or reaction of alcohol. So, they are involved two cleavage. Okay, so the first cleavage is between RO and H. Second cleavage is between ROH. And the third reaction of alcohol chemical properties is oxidation. Okay. 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 If you have any problem or if you want to ask a question, please write in comments. Okay. So for the alcohol cleavage of R, O, and H, so it will eliminate H. So the reaction will involve reaction is reaction with sodium metal and esterification. Okay, reaction which involve cleavage of ROH, which is OH is eliminate, kita singkirkan OH. The reaction is dehydration of alcohol. Okay, actually this one we refer previous chapter, which is chapter alkene, and substitution reaction with HX. HX is the X is halogen, EX3, PCl5, and SOCl5. Okay. Oxidation by using strong oxidizing agent. Okay, the example of strong oxidizing agent is cadmium permanganate acidic heat, calcium chromate acidic heat, sodium chromate acidic heat, hydrogen chromate acidic and heat, or by using the mild oxidizing agent, which is ECC in CH2Cl2. Okay, so first uh, we will discuss the first reaction of alcohol. So when your alcohol is reacted with sodium metal, so alcohol react with sodium to form sodium alkoxide and release hydrogen gas. So in this case, KROH is an alcohol. Okay, so sodium is a metal base, logam berbase. So alcohol will act as acid. So kita dah belajar masa first sem definition of acid. Acid is a species that will donate proton H plus. So alcohol dia akan break the bond between H and OH by release ataupun donate H plus. So kemudian dia akan produce RO minus. RO minus reacted with metal base sodium, produce sodium alkoxide and hydrogen gas is produced. Ini ialah tindak balas antara. Ini ialah general equation for acid react with metal base. Belajar form 4 of 1-5, dia akan produce salt, garam and hydrogen gas is released. Okay. So example, CH3, CH2OH, so this is ethanol, which is a type of alcohol, react with sodium. Ethanol will, bila dia react with sodium metal, so kita tahu sodium metal is metal base, so dia terus act as acid. By donating H+, okay, so dia akan jadi CH3, CH2O minus, okay, combine with sodium metal, jadi sodium, sebab ethanol is toxic, hydrogen gas is released. So kita balancekan, sini hydrogen ada 1, hydrogen gas formula is H2, so kamu kena letak 1/2. So tanda arrow kat atas ni menunjukkan this is release, hydrogen gas is released. Okay, second example, this is cyclohexane diol, 1, 2, 3, 4. 1, 4 cyclohexane diol ataupun cyclohexane 1,4 diol. Okay. Reacted with sodium, so both akan release hydrogen gas. Okay, dia akan act as acid. Dia akan donate H+, dia remove, donate H+, ni pun donate H+. Okay, so jadi O minus, react with sodium jadi O minus Na+, O minus Na+, hydrogen gas is released. So yang ni tak perlu letak half sebab kat sini hydrogen ialah H2, the molecular formula. So kat sini H ada 1, 2, so letak kat sini 2. So this reaction show the acidic properties of alcohol. So we can conclude that alcohol is an acidic solution. Okay, so ini membuktikan alkohol itu bersifat sebagai asid. Okay, so second is esterification. Okay, esterification. So when you have ester, ester RCOR can be formed through the reaction of alcohol and carboxylic acid, alcohol and acid chloride. So first, you must remember the structure of ester. Ester is R, C double bond O, O, R prime. Okay. So C double bond O, R, this is the structure for ester. Okay. Alcohol react with carboxylic acid under reflux and catalyzed by acid H2SO4 or HCl to form an ester and water. So example, so this is carboxylic acid RC double bond OOH. So this is an alcohol. Alcohol will break the bond between O and H. Carboxylic acid will break the bond between OH. So it will release H, 1H, 2H, H2, H, 1H, 2H, H2O. So H2O yang purple ni contribute by alcohol, OH is contribute by carboxylic acid. So it will produce RC double bond O, OR prime. Okay. Example, CH3, CH2, COH, propanol acid and methanol. So methanol will break the bond between O and H. Carboxylic acid will give OH. So dia akan combine. Okay. So that it will produce CH3, CH2, C double bond O. So this one is from carboxylic acid. O CH3 is from methanol. So the name is methyl from alcohol, methyl propanoate. Okay, side product is H2O. So make sure kamu boleh combine, tahu dekat mana ikatan tu bersambung. Okay. Alcohol can also form an ester by react with acyl chloride. Acyl chloride ialah RC double bond OCl. Okay, so this is the structure for acyl chloride. Okay. So an acyl chloride react with alcohol. Alcohol will break the bond between O and H. Acyl chloride will break the bond between C double bond O and Cl. So dia akan combine kat sini. Okay, dia akan produce HCl. So the main product is RC double bond O, OR. So this one is from alcohol. This one is from acyl chloride. So RC double bond O, R is the structure of ester. Okay, example. So this is ethanol chloride sebab ada satu dua dua carbon ethanol chloride react with methanol. Okay, H combine with Bl produce HCl. So dekat mana dia combine? CH3C double bond O. So this is from ethanol chloride. Okay, combined with O, CH3 is from alcohol methanol. So it will produce methyl ethanoate. Okay, now we want to study the bond cleavage of okay, C and OH. Okay, so kita punya example sebelum ni tadi, ini adalah bond cleavage between OH and C. Okay, kat sini. Okay. So, dehydration of alcohol, actually this one is, you refer the chapter alkene. Refer chapter alkene dekat mana? Refer chapter alkene masa chapter synthesis of alkene. So, pembentukan alkene. Synthesis of alkene from dehydration of alcohol. Okay. Okay, so example. So kat sini. Okay. So alcohol heated with concentrated sulfuric acid or phosphoric acid to form an alkene and water. The major product form is will follow Saizer's rule. So what is the Saizer's rule? So what is the Saizer's rule? So Saizer's rule state that the major product of alkene is the most substituted okay alkyl substituted carbon double bond. Kalau nak buat ayat je lah. So this is the example. The major product of alkene is the most stable alkene. So the most stable alkene, which is the mostly substituted mostly substituted alkyl substitute apa alkyl group to carbon double bond. Okay. Example, so this is the example. So from your lecture note, the example is 1, 2, 3 propanol. Propanol is CH3, CH2, CH2OH. If reacted with H2SO4 concentrated and heat. Okay, so kalau saya kembangkan struktur ni, CH3, okay, CH2, CH2, OH. Okay, so for this alcohol, so dia akan remove water H and OH from the adjacent carbon. So dia akan jadi, your product will be so the alkene will be CH3, CH, so normal single bond dah jadi double bond, CH2, so dia jadi alkene. So dekat sini pun double bond, dekat sini pun double bond sama. Okay, so in this case dia akan bond cleavage between carbon and OH. The second example is this one. When reacted with H2SO4 concentrated and heat, so carbon. So 1, 2, 3, 4. Okay. So carbon ni 1, 2, so ada CH2. So actually there are two possible structure of alkene will form. Ni adalah CH3. So kalau dia remove H and OH from this adjacent carbon, so your product will be, so kat sini lah double bond dia. Ini jadi CH2. Okay, plus if you remove H and OH here, so your product will be ini CH3, so saya tak baca. So double bond will be formed here. Okay, so between these two, because of there are two products, so yang ni single product, and because of these two products, so you need to determine the major and minor. So this double bond CH2 ni bukan alkyl group Okay, alkyl group yang this one. So dia ada one alkyl group. So untuk carbon yang ni ada berapa alkyl group? One alkyl group. So dia ada two alkyl group. So this one will become the major product based on size. This one is a minor product. Okay, the most highly substituted carbon-carbon double bond. Okay, so cuma saya nak fokus kat sini yang this reaction is involve bond cleavage between carbon and OH. Okay, next is okay. So this one I have already discussed. Okay, next is substitution reaction by using HX, PX3, PCl5 or SOCl2. So this reaction involves the substitution of OH group with halogen atom to form haloalkane alkyl halide. So general reaction. So if you have alcohol react with HBr, so dia akan undergo bond cleavage between R yang mana sini alkyl group carbon dan OH. So dia akan substitute OH minus dia akan substitute with Br minus, so jadi R Br, okay, haloalkane. So ini pun sama, OH minus substitute with Br, so it will produce RBI, sub product is HOP Br2. So this one is also OH minus substitute with Cl minus. So dia akan jadi chloro halo. This is also a type of haloalkane. So dia akan decide product is HOPCl2. Alcohol react with PCl5, OH substitute with Cl. So dia akan jadi RCl haloalkane. COCl3 plus HCl is your third product. Okay, OH minus substitute with Cl. Okay, in pyridine, it will produce RCl, haloalkane, SO2 plus HCl is the third product. So you can conclude that when alcohol can reacted with HX or PX3 or PCl5, so dia akan produce ini haloalkane. Okay, the type of reaction, nama tindak balas yang dilakukan ialah nucleophilic substitution reaction. So what is your nucleophile? OH minus is nucleophile. Substitute with X. Substitute with X, which is X minus, which is halogen. Okay, example, the general equation. So this is the general equation. R is alkyl group, Br is bromide. So example, this is alcohol react with HBr, OH is substitute with Br. So jadi macam ni, haloalkane. OH substitute with Cl. So this is a haloalkane. Okay. The next reaction is reaction of alcohol with HCl. Alcohol react with concentrated HCl in presence of ZnCl2 to produce haloalkane and water. The ratio of concentrated HCl and ZnCl2 is known as Lucas test. Ini yang kita buat eksperimen minggu ini. So, please remember the reagent. This is the reagent. Okay, so the reagent is the name of test. Okay. The name of test is Lucas. So the reagent is HCl concentrated. Okay, ZnCl2. Actually, ZnCl2 is the catalyst. Okay, so Lucas reagent can be used as a chemical test to differentiate the class of alcohol. So what is the purpose ataupun what is the reason we do the Lucas test? To identify class of alcohol. So general equation, so I want you to write this equation in the lab report. So if you have an alcohol react with concentrated HCl in ZnCl2, OH will be substituted with Cl, so it will produce RCl and H2O. So RCl is a haloalkane, H2O is water. Haloalkane is cannot form hydrogen bond with water. So bila dia cannot form hydrogen bond in water, dia insoluble in water. So bila insoluble in water, so kamu akan observe, your observation is you will get two layers solution form. Sebab itulah kamu dapat cloudy solution. So kalau cloudy solution tu, kalau kamu letak dan tunggu lama sikit, kamu akan dapat two layers. Because haloalkane form is insoluble in water. Okay, so general reaction. So if you have an alcohol, react with this PX3, OH substitute with halogen, produce RBr and H3O3. So OH substitute with Br, so dapat bromo, 1 bromo cyclopentane. So this one OH substitute with Cl, so dia akan dapat haloalkane this one. Okay, so this is the general reaction for equation for alcohol react with BCl5. OH is substitute with Cl, produce RCl. So OH substitute with Cl, dia akan jadi haloalkane. This one. Okay, so this is the general reaction between alcohol and SOCl2. So OH substitute with Cl. In pyridine, it will produce RCl, SO2, and HCl. Example, 1, 2, 3. 1 propanol react with SOCl2 in pyridine. OH is substitute with Cl. So it will produce CH3, CH2, CH2Cl. So this is 1 propane. It's a type of haloalkane. Okay, so oxidation of alcohol. So actually we have do this experiment during your lab. So you use um, oxidizing agent that you use is sodium dichromate in acidic and heat, this one. So actually there are some others strong oxidizing agent that can be used for oxidation of alcohol. So that is potassium permanganate, cadmium permanganate in acidic heat, potassium chromate, K2Cl2O7 in acidic and heat, sodium dichromate, as I mentioned, chromic acid, hydrogen chromate, okay, ataupun chromate in acidic and heat, sodium dichromate, PCC, CH2Cl2. Sodium dichromate PCC is the only weak oxidizing agent. So oxidation product depends on the class of alcohol and the oxidizing agent used. Okay, so actually this one I also have already discussed in the lab also. So if you have a primary alcohol is oxidized to aldehyde and aldehyde form is then easily oxidized to carboxylic acid. Okay, so okay, so requirement of an alcohol to undergo oxidation is dia mesti ada at least one hydrogen atom attached to carbon which is bonded to OH. Okay, so kalau primary alcohol, carbon bonded to OH, bonded to one neighboring carbon. So this is H, H. So ini ialah primary carbon. So ini ialah primary alcohol. So primary alcohol, okay, when undergo oxidation, with oxidation dia mesti tambah oxygen, remove water. So dia akan remove H2O, so dia akan jadi C. So let's say sini ialah CH3. So CH3, C, C, dia akan jadi double bond. Ini dia kembang jadi double bond. Oxidation ditambah oxygen, okay, jadi H is retained, dia akan jadi aldehyde. Okay, tapi bila kamu if strong oxidizing agent use, kalau kamu gunakan strong oxidizing digunakan, contoh example strong oxidizing agent is example adalah sodium chromate yang macam kamu buat kat lab tu, acidic and heat. Aldehyde ni dia akan reoxidize ni dia akan reoxidize jadi CH3, C double bond O, OH. Jadi carboxylic acid. So I do the summary of oxidation. The oxidation ada dua, by using strong oxidizing agent ataupun weak oxidizing agent. So oxidation dia mesti required at least one hydrogen atom bonded to carbon OH. Okay, so we discuss one by one. So for primary alcohol, for example, CH3, C, H, OH, H. So this carbon bonded to one hydrogen carbon, so this is primary carbon. OH bonded to primary carbon is one to ethanol. Ethanol is a type of primary alcohol. So when primary alcohol undergo oxidation by using, let's say, cadmium permanganate, acidic and heat. So macam saya cakap lah, oxidation dia mesti jadi masukkan oksigen. Oxidation ni ialah tindak balas yang add oxygen and remove H2O. Dia tidak balas oxidation. So dia akan jadi CH3, C, okay, dia jadi double bond O, H, yang 1, 2 inilah ethanol. Ethanol is a type of aldehyde. Okay, sebab since strong oxidizing agent is used, sebab kita gunakan enzim peroksidan yang kuat, okay, aldehyde will reoxidize to form carboxylic acid. Sebab kita guna strong oxidizing agent, jadi akan jadi dia akan reoxidize. Dia akan jadi CH3, C double bond O, H ialah OH, ini ialah ethanoic acid. Ethanoic acid is a type of carboxylic acid. Okay, so this is for primary alcohol. So we use the same example, which is ethanol. Primary alcohol reacted with PCC. Reacted with PCC in CH2Cl2, reacted with PCC in CH2Cl2. Okay, please remember, PCC in CH2Cl2 is a type of weak oxidizing agent, sejenis agent oksidan yang lemah. So macam saya mention, oxidation dia mesti akan remove H2O and add oxygen, tidak akan jadi CH3, C double bond O, H. Ini ialah ethanol. Ethanol is a type of an aldehyde. Okay, so since the oxidizing agent used is weak oxidizing agent, so aldehyde form will not reoxidize to carboxylic acid. So dia akan stop sampai aldehyde saja. Okay, kalau kamu tanya saya, kenapa primary alcohol boleh undergo oxidation? Sebab karbon yang terikat dengan OH ni, dia ada dua hidrogen. So, dia boleh undergo oxidation. Okay. Okay, so let's continue with secondary alcohol. So secondary alcohol undergo oxidation. Okay, example secondary alcohol. So OH attached to this carbon attached to two neighboring carbon. So CH3, OH. So this carbon is secondary carbon sebab dia attached to dua metal. So dia ialah secondary alcohol. Okay, so the name of this compound is 1,2,3. 2-propanol. Okay, react with let's say sodium chromate guna oxidation agent lain, acidic and heat. Ini a type of oxidizing agent. Okay, saya saja tulis cara penulisan saya macam ni. So maksudnya cara penulisan kamu boleh buat macam ni atau macam ni. So both accepted. Jadi saya nak ingatkan yang dekat bahagian bawah ni ialah condition. Okay, saya dah kata oxidation dia mesti add oxygen and remove water. So dia akan remove water dekat sini, add oxygen dia akan jadi CH3C double bond. Dia masuk add water, dia akan jadi double bond. Yang saya combine jadi double bond, masukkan oxygen O CH3. So side product dia adalah H2O. Jadi kita tak insert tuan yang satu product sebab kita tak balance coefficient. So 1, 2, 3 ini adalah propanol. Propanol is a type of ketone. So you can conclude that secondary alcohol kalau undergo oxidation dia akan jadi ketone. Dan kenapa secondary alcohol can undergo oxidation? Sebab pada karbon yang terikat dengan OH ni, karbon yang terikat dengan OH dia ada satu H. So dia boleh undergo oxidation. Ini adalah bila secondary alcohol dengan strong oxidizing agent. So kalau secondary alcohol dengan weak oxidizing agent macam mana? So saya guna contoh yang sama, CH3, OH, ini ialah H, dengan weak oxidizing agent ialah PCC, CH2Cl2. So actually dia akan produce benda yang sama, CH3, C double bond O, CH3. Dia pun akan jadi ketone propanol. Kenapa aldehyde dia boleh reoxidize? Sebab aldehyde ni dia ada satu lagi atom H yang dia boleh tukar H ni dengan oksigen. Okey, faham ke? Okay. So sekarang kita nak tengok tertiary alcohol undergo oxidation. Okay. Tertiary alcohol, example COH, CH3, CH3. So OH attached to this carbon attached to 1, 2, 3 neighboring carbon. So this is tertiary carbon. OH attached to tertiary carbon adalah tertiary alcohol. So the name for this compound is 2-methyl 2-propanol. 1, 2, 3. Okay, itulah. Okay, when reacted with strong oxidizing agent, hydrogen chromate, acidic heat. Kita tengok saya guna oxidizing agent yang lain sebab saya nak tunjuk itu ialah contoh-contoh oxidizing agent. So COH, karbon yang terikat dengan OH ni, dia tak ada satu atom hidrogen pun. Semuanya ialah karbon. So tertiary alcohol ni cannot undergo oxidation. Okay, dengan strong pun tak boleh, apatah lagi dengan weak. Dia something tertiary alcohol dengan oxidation dia no reaction. Sebab tu eksperimen kita yang minggu ni kita guna 2 meter ketopanol, kamu dapati the orange color of sodium chromate is remain unchanged. Dia warna orange. Okay, so ini kita dah cover secondary also dah, tertiary dah. Okay, tertiary alcohol does not have hydrogen that is directly attached to the carbon bearing of OH. Yang kita cakap tadi tu, iaitu carbon alpha. So therefore, tertiary alcohol will undergo reaction oxidation, no reaction. So cannot undergo oxidation. So as a summary, primary alcohol by using the yang atas ni ialah strong oxidizing agent. So primary alcohol using strong oxidizing agent become carboxylic acid. Primary alcohol dengan weak oxidizing agent dia akan jadi aldehyde. Secondary alcohol dengan strong or weak both jadi ketone. Tertiary dengan strong or weak both no reaction. Okay, so for identification test, so I will continue this Friday. Identification test and the acidity of alcohol. Okay, so I think that's all for now. Okay, thank you.